Swayam Prabha. Digital India. Educated India.
Welcome, dear students, in our series of lectures on pharmaceutical production technologies. Myself, Dr. Ajay Semelty, again welcome you. Today, we are going to discuss the disperse system production. In this particular lecture, we are going to discuss the solid dispersants. We will discuss what are these and how we can prepare these solid dispersants. So let's enjoy this lecture. After going through this lecture, you will be able to understand the concept of solid dispersion, methods of preparations, applications and their processes, and obviously about their characterization. We will cover this lecture with definitions of solid dispersions, their advantages, limitations, classification of methods of preparation, but then processes, applications, and at last the characterization. In the beginning of this lecture, let's define solid dispersion first. These are composite of solid of one or more drugs in water soluble carrier or matrix prepared by melt, fusion, solvent or melt solvent method. Various inert but water soluble carriers like urea, PVP, PEG and several other polymers are used to develop the solid dispersants. What are the advantages of solid dispersants? They are very useful in improving the solubility as well as the dissolution rate of the drug. And we have discussed this thing. You have studied this thing in as a solubility improvement technique or dissolution improvement technique. And hence the bioavailability is also improved with solid dispersants. It enhances the dissolution of drugs by the formation of fine drug crystals via the eutectic or monotectic system. These systems generally provide the particles with good micrometallic properties. Apart from solubility and dissolution enhancement, and also it's a size reduction, good size reduction technique also. It's suitable for thermolabile substances also because we are not heating the things in most of the processes, and if we are heating, we can employ the vacuum to lower down the boiling point, so the thermal degradation is least. What are the limitations of solid dispersants? Many times, or you can, in some particular carriers, the resultant solid dispersants may be having the increased hygroscopicity, and the success of solid dispersion depends on the material and API and its compatibility and their compatibility in between them. Now let us discuss what is the actual concept of solid dispersion. Under certain conditions, the drug may be entrapped in the water soluble carrier matrix without undergoing recrystallization to form an amorphous solid solution. A water soluble matrix with the carrier or it may dissolve in the carrier to form a true solid solution. Yes, solid solution. This is the key aspect of the solid dispersion, that it forms a solid solution. The drug particles in solid dispersion were released as fine or amorphous colloidal entities upon dissolution of the matrix, and thereby enhancing the drug dissolution rate. The concept is deemed to be utilized for drug enhancement if the drug and the water soluble carriers have been fused prior to or during granulation via any of the three preparation methods. Yes, what are these three preparation methods of preparing these solid solutions? Let's discuss. These methods which we have discussed, that yes, melt solvent and melt solvent method, they can be used to prepare the solid dispersions. The drug can be dispersed molecularly. In these methods, what is happening? Drug is being dispersed molecularly in amorphous particle or in crystalline state. Three different things: amorphous, molecular dispersion, amorphous, and crystalline. And in these three characteristics, based on this molecular arrangement, the solid dispersions may be of six different types. Yes, six different types. Type 1 is called eutectic. Eutectics are having the matrix and drug both crystalline. Type 2, amorphous precipitation in crystalline matrix. Type 3, solid solutions. They may be continuous solid solution, discontinuous solid solution, substitutional solid solution, and interstitial solid solution. In this type 3 solid dispersions, matrix is crystalline and drug is molecularly dispersed in the system. While in the type 4 type of solid dispersions, glass suspension they are called. In this, matrix is amorphous and the drug is crystalline. While in the type 5 glass suspension, matrix is amorphous and drug is amorphous. Matrix and drug both are amorphous here. While in the type 6 glass suspension, matrix is amorphous and drug is molecularly dispersed. So depending on these three conditions, whether the drug is molecularly dispersed or it is amorphous or it is crystalline, we can divide or we can classify the solid dispersions in the six types. Type 1, let me summarize these types. Type 1 is eutectics, matrix and drug crystalline. Type 2, amorphous precipitations in crystalline matrix. Type 3, solid solution of continuous, discontinuous, substitutional, interstitial matrix crystalline, and drug is molecularly dispersed in type 3 system. While in the type 4 system, glass suspension, matrix is amorphous, drug is crystalline. In type 5, glass suspension, both are amorphous. In type 6, matrix is amorphous and drug is molecularly dispersed. So you might have got the reason behind or the basis behind the classification of the solid dispersals. Now let us see the three methods which we were talking about. First is melt fusion method of preparing the solid dispersion. Melt when it is in crystalline form, okay? Fusion when the components are in amorphous form. Solvent removal or evaporation method is the second method, while the melt solvent method, which is a hybrid method of these two methods, are when we combine these two methods, we lead to the melt solvent method. Now let us discuss these methods in detail individually. Melt or fusion method. Utilize the melt or fusion to produce the dispersed systems. Essentially, a physical mixture of a drug and a water soluble carrier was heated directly until melting occurred in this method. The molten mixture, which is obtained after heating the carrier and the drug, was subsequently solidified in an ice bath, and the cooled mass was milled and sealed. Administration of the product obtained was found to improve absorption of the drug. However, many studies have been done on the variation of these methods. They may have the various versions of this method, modification of this method. What are these processes by which the melt fusion method or melt or fusion method can be achieved? Compression molding, extrusion spheronization, melt extrusion, hot spin, melting, in situ granulation, melt granulation, roll mixing, ultrasound assisted compaction, and ultrasound assisted spray congealing. So these are the various processes by which the preparation of solid dispersion can be done with the help of melt or fusion method. Now moving to this very common method, solvent removal evaporation method, and most of us employ this method in the laboratories. It involves dissolving the drug and the water soluble carrier in a common solvent and subsequent evaporation of the solvent under vacuum. Solid dispersions produced by this method are commonly called as co-precipitates. Co-precipitates are formed by the addition of a second solvent to the original solution, which decreases solubilities of the drug and carrier in the resulting solution. Note it down, co-precipitation decreases the solubility here. So thus co-precipitating them, then what is happening? Then the ultimate, after the co-precipitation, we get the solid dispersion. Solvent removal method, what are the processes we can adopt for getting this method? There are various versions. Lyophilization, with the help of lyophilization, solvent deposition, solvent extrusion and spheronization, spray drying, spray freezing into liquid, stream granulation, and supercritical carbon dioxide method, supercritical method. So these are the processes by which the solvent removal can be done. Any of the method or the combination may be utilized for efficient solid dispersion preparation. Now moving to the third method, that is melt solvent method. It is a hybrid of the two method, melt method and solvent method. The drug is dissolved in a suitable organic solvent and the solution is incorporated directly into the molten carrier. Subsequently, the organic solvent is evaporated off. So we are melting as well as the solvent removal. Both the things are being done here in this method. This is the hybrid method. As far as the processes are concerned, let us discuss some of the important processes in preparing the solid dispersion. Number one is melt extrusion process, in which conversion of a raw material into a product of uniform shape and density is done. The drug and additives are usually mixed, followed by forcing the powder mass through a die under controlled condition. The extruded mixture always exhibits more rapid release of drugs versus the corresponding physical mixtures. Okay. In case of extrusion spheronization process, it is a modified process of melt extrusion process. The extrudates are spheronized to form pellets which are highly spherical granules. Enhanced release was achieved by addition of sodium lauryl sulfate SLS and sodium starch glycolate SSG, which respectively acted as the surface active agent and super disintegrant in many of the studies. So by using the surfactant or super disintegrants, the enhanced release or improved release can be achieved. Okay. Now moving to the another process, melt granulation process. In the melt granulation process, what we do, powders are agglomerated with the aid of a binder in either a molten state or solid state that melts during the process. The apparatus of choice is high shear mixture, where the temperature of a powder can be raised above the melting point of a melting binder by either a heating jacket or frictional forces generated by the impeller blades. The liquid binding is possible by the molten binder, thus melting granules does not require the use of solvents. The choice of the meltable binder plays an important role in this process. It has to be melt at a relatively low temperatures at 50 to 80 degrees Celsius. The use of hydrophilic binder that melts at a low temperature will aid in the rapid release of the drug. Now moving to next process, that is roll mixing process. The feeding of the powder mix through two rollers is done here. In this method, the powder mass usually includes the drug with one or more water soluble carriers, and depending on the appropriate processing conditions such as roller pressure or the use of solvent, the drug may be converted into an amorphous state. Lyophilization. It is also one of the most important process of solvent removal, which we have studied exclusively in a lecture which we have discussed in the drying technologies. Please do refer lyophilization in detail if you want to go through. Please do refer that particular lecture of our this lecture series in which we have discussed the lyophilization in detail. To briefly describe lyophilization or freeze drying is a process whereby water is sublimed from frozen solutions, frozen suspensions or frozen emulsions under reduced pressure and temperatures well below the triple point, remember, leaving a dry porous mass of approximately the same shape and size as the original frozen mass. So below the triple point, well below the triple point, the temperature and pressure are maintained, and then the solid can be sublimed. So that's why it is called sublimation drying also. So lyophilization, freeze drying, sublimation drying. Another name is there. Please do recall that particular name of lyophilization. Lyophilization or freeze drying essentially consists of three steps. Number one, freezing, primary drying, and secondary drying. The material is cooled until they are frozen in the first stage. Primary drying is accomplished under vacuum and slight heating to remove most of the water by sublimation. And the last stage is to remove the sopped water which is carried out under elevated temperature. So secondary drying is done, and thereafter we do the packaging itself. So freezing, primary drying, and secondary drying. These are the three methods which are employed in the lyophilization. So after going through this lyophilization as a method of solvent removal for developing the solid dispersions, let's discuss the next process, that is steam granulation process. It's a derivative. This process is the derivative of wet granulation technique, which involves the use of steam instead of traditional liquid binder. Instead of spraying the liquid binder, steam is emitted into the wet mass chamber. The processing time is short because less moisture is needed, as steam has a high diffusion rate into the powder mass, achieving a high distribution of the binder. Another reason is the more favorable thermal balance during the drying step. This is because after condensation of the steam in the powder mass, water forms a hot thin film, and this requires only a small amount of energy for vaporization as compared to evaporating the water from the room temperature. So this was about the steam granulation. Now, what is supercritical fluid method? It is an advanced method. It is applied with carbon dioxide as solvent of drug and matrix or as an anti-solvent. When supercritical carbon dioxide is used as solvent, matrix uh, and drug are dissolved and sprayed through a nozzle into an expansion vessel with lower pressure and particles are immediately formed. The adiabatic expansion of the mixture results in rapid cooling. That flash cooling is done here. This technique, the supercritical fluid method SCF, does not require the use of organic solvents, and since this carbon dioxide is considered an environment friendly gas, this technique is referred to as solvent free technique or green technique you say. This technique is used as is also known as RESS. What does the RESS mean? Rapid expansion of supercritical solution. Okay, RESS. However, the application of this technique is very limited because of the solubility in CO2 of most pharmaceutical compound is very low, less than 0.01 weight% and decreases with increasing polarity. So that's why it's of limited use in pharmaceutical purpose, but yes, it is one of the most advanced methods nowadays. Therefore, scaling up especially this process in kilogram scale will be impractical. All other supercritical fluid techniques are precipitation methods. Although generally labeled as solvent free, though they are called solvent free, all the supercritical fluid methods use organic solvents to dissolve drug and matrix and exploit the low solubility of pharmaceutical compounds in carbon dioxide. In fact, these techniques represent alternative methods to remove the solvents from a solution containing typically a drug and the polymer. So these GS, gas anti-solvent technique, is another subtype of supercritical fluid method. In gas, it is also called precipitation technique or precipitation from gas saturated solution. The two names are GS, gas anti-solvent solution, or precipitation from gas saturated solution, PGSS. The solution is brought into contact with compressed carbon dioxide. The conditions are chosen so that CO2 is completely miscible with the solution under supercritical conditions, whereas drug and matrix will precipitate upon expansion of the solution. When the volume of the solution expands, the solvent strength, that too you can say that the ability to dissolve the drug decreases, that solvent strength decreases. This results in precipitation of matrix and drug, and since this technique is often applied with PEG as matrix, polyethylene glycol as matrix, this technique results in the formation of a solid dispersion with a crystalline matrix. Okay, the resultant product is a crystalline matrix. Now next method in the same category, supercritical fluid method, precipitation with compressed anti-solvent, PCA. It involves the spraying of a solution containing drug and matrix through a nozzle into a vessel that contains a liquid or supercritical antisolvent. The supercritical antisolvent rapidly penetrates into the droplets in which drug and matrix become supersaturated, crystallize and form particles. More specific examples of PCA are supercritical antisolvent, SAS. When supercritical CO2 is used, or aerosol solvent extraction system ACS, and solution enhanced dispersion by supercritical fluids SEDS. So these are subtypes of these methods is ASES, aerosol solvent extraction system, or solution enhanced dispersion by supercritical fluids SEDS. So these are some important supercritical fluid methods and their sub methods, called as solvent free, but yes, we do use some solvents. Now moving to the characterization of solid dispersions. How we can determine, how we can characterize the solid dispersion for various parameters. Solid state characterization, which we have discussed in the pre-formulation, you might have studied for the crystal structures, FTIR, XRPD, NMR, nuclear magnetic resonance, DSC, the thermal analysis, SEM, okay. And much more spectroscopic techniques can also be utilized, like UV spectroscopy can also be utilized, NIR can also be utilized. Apart from that, the physical parameters like solubility, because it is a solubility enhancing technique, so you must see the change in solubility with the standard methods. Micromeretic properties like angle of repose, density, and other parameters can be characterized. And the last but not the least, the in vitro dissolution or the drug release, because they are prepared for improving the solubility and the dissolution. So solubility and dissolution are utmost important characterization parameters, and because the change in crystal structure may be determined by the various solid state characterization, we can perform solid state characterization. Specifically, XRD provides the technique which shows if there is a change in the peaks with respect to the intensity or sharpness. If the peak becomes diffuse, it means the crystal structure is has been converted into the amorphous one, and so on. With the help of various spectroscopy techniques, the change in peak in the thermal analysis is evident of the change happening there. So please do refer the previous lecture in which we have discussed these techniques. These are some of the further readings and the bibliographic for and the references for your further reading. Please do refer these references. Now let me summarize what we have learned out of this lecture. What are solid dispersions? They are composite solids of one or more drugs in a water soluble carrier or matrix. Depending upon their uh, crystallinity, they can be of 6 types. There may be the 6 types of solid dispersions, whether they are amorphous, crystalline, or molecularly dispersed. If the drug is amorphous, crystalline, or the molecularly dispersed, depending on these 6 types of solid dispersions we have studied. We studied their advantages, solubility, dissolution, and hence the bioavailability is expected to be released. Solubility and dissolution is obviously directly you can observe, and then for obviously the bioavailability you need to perform in bio studies also if you want to go through with the advanced studies. And just utility, we can utilize them for various solid dosage forms. The method, 3 major methods we discussed. First is fusion method, solvent, and then melt solvent method. The third method is the hybrid method, which utilizes these things and the various processes through various processes like extrusion, spheronization, melt granulation, steam granulation, supercritical fluid technique, lyophilization. We have discussed all these techniques, the major techniques for preparing the solid dispersion through these 3 major methods. As far as the characterization of solid dispersion is concerned, the solid state characterization parameters must be checked. FTIR, XRD, NMR, DSC, thermal analysis, other spectroscopy techniques, and after that solubility, dissolution, bioavailability, and then micromeretic properties, various like angle of repose and bulk density, pore density, tap density, and last but not the least, in vitro dissolution study or in vitro drug release study can be characterized for the solid dispersions. This was all about the solid dispersion. However, you must go through the various techniques and the instruments, the equipment which can be utilized for these for developing the solid dispersions at the mass scale, or how the scale up can be done for these techniques. And please do practice developing the solid dispersion in your laboratories so that you can come to know that what was the change which was brought about by the development of solid dispersion in the drug. check the solubility, check the dissolution. Okay, these simple things you can have if you are having FTIR, you can see the changes. So unless you do these things experimentally, practically in your laboratories, you won't get much out of this topic. You will have, you must have the experimental approach in learning these topics. So best of luck for your learning. Thanks for being with us. Happy learning.